Hello, Mr. Marcel. So today I'm here with Zahran. We're going to explain about the implicit function and the parametric function of differentiation. So we chose example 4D number 5 and example 4.22 for number 5 is the implicit function and the 4.22 is parametric equation. So firstly, so this is our answer to number 5. So the question is find the stationary points for equation x squared plus y squared plus xy equals to 3. So the first step, we need to differentiate each and every one of them. So to x plus to y divided over dx plus, and using the product rule to find xy, hence 1 times y plus dy over dx times x equals to 0, because if we differentiate 3 or any integer, it becomes 0. So, and then to x plus to y divided over dx plus the product of this plus y plus x divided over dx equals to 0. Since it's equals to 0, we can cancel out both 2y divided over dx with x divided over dx, so it will be cancelled. So 2x plus y equals to 0. Hence, we make y as y equals to minus 2x. So we just put the y over here in the original function. So x squared plus in the bracket minus 2x squared plus x times minus 2x equals to 3. It becomes x squared plus 4x squared minus 2x squared minus 3 equals to 0. We minus this one and this one, so x becomes minus x squared plus 4x squared minus 3 equals to 0. And we make it like this, 3x squared equals to 3, and hence x squared equals to 1. So the two x's are x, the first x is 1 and the second x is minus 1, since there's a square here, so you make a root of plus minus 1. And then you just put each one into this function or any other function, and it will be the same. So y1 equals to minus 2 and y2 equals to minus 2. Next, Zahran will explain the parametric function.
Okay, so for me, I'm going to explain the example 4.22, which is a parametric question. There's 3 parts of the question: I, double I, and triple I. So the question is, a curve has a parametric equations x equals to t2 and y equals to 2t. For the first I, we need to find the dy over dx. How to find dy over dx? So first, we need to make the x and y become dx over d2 and dy over d2 dt respectively. So for dx over dt, we write it as 2t because it is t square, so the square moves to the left and it became 2t. So for dy over dt, it became 2 because there is only one t, so like we eliminate the t and it becomes 2 only. So to find dy over dx, we need to write dy over dt and dx over dt. So we put the informations that we get from here to the equation. So it became 2 over 2t, and then we eliminate the 2, so it became 1 over t. Okay, for the double I, we need to find the equations of tangent at general point t squared and 2t. The equation we write the equation of tangent formula, which is y minus y1 equals to m, the gradient that we get from the first I, and x minus x1. So y minus 2t, where did we get the 2t is from here, the question. So we put it in y first, and then m, the gradient, 1 over t, so we put it here, and then x minus x1. X1 is the first letter here, so it is x minus t squared. So y minus 2t equals to 1 over t x minus t. So this is the equation of tangent at general point t squared 2t. And then last part of the question is triple I. We need to find equation of tangent at point t equals to 3. How do we do this? So we put the t is equals to 3, right? So we put 3 in t. So it became y minus 2, 3 in bracket, and then equals to 1 over 3 x minus 3. How do we get this equation? We get the equation from the previous part, which is this one. And then move on. We multiply the 2 and 3, it became 6, and then 1 over 3, multiply it in the bracket, so it became y minus 6 equals to 1 over 3x minus 3. And then we move the number to the right side, so it becomes y equals to 1 over 3x minus 3 plus 6. It became y equals to 1 over 3x plus 3. Now the y became now we can find the y now. So it is y equals to 1 over 3x plus 3. Now, since we don't want to have a fraction in our equation, we times 3, so the 1 over 3 becomes 1. Now, the equation becomes 3y equals to x plus 9. However, you can stop at this part, which is y equals to 1 over 3x plus 3. But we decided to end it here, so it will look clean. Okay, that is all for our group. Thank you for watching.